Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in today's class we are going to continue the chapter motion, and this is 8th period of this chapter. We are in the last part of the chapter, and before going to that last part, just we shall recall yesterday's concept. That is, we solved many problems on equations of motion. How many are there? There are 3 equations of motion. Yes, what are those? First one is V equal to U plus AT. Second one is S equal to UT plus half AT square. And third one is 2AS equal to V square minus U square. Now, let's go for solving some more important numerical problems by using these equations. Here, I have written 2 such questions. Go through this. The first one, a racing car has a uniform acceleration of 4 meter per second square. What is the distance will it cover in 10 seconds after start? Did you understand? Once I read, and while reading only, just let's go for writing the data. A racing car has a uniform acceleration of 4 meter per second square. What does it represent? Yes, it is A, 4 meter per second square. What distance will it cover in 10 seconds? Where 10 seconds is time. How much distance it will cover? That is, yes, after start. After start means its initial velocity was 0 meter per second. Right? So with this information, now we have to find out the displacement. Then which of these equations of motion can be used? We know that ATU we want yes. ATU we want yes. Can we go for using the second equation? Yeah. Let me write that. Calculation. Here because they are not asked the final velocity. Only initial velocity has been given. After it start means, so before starting it was at rest. When the body is at rest, its velocity will be 0. Hence we have taken initial velocity as 0 meter per second. Now from equation of motion, what is that? It is S equal to UT plus half AT square. Substitute. What is U? 0. T, time is 10 seconds. Plus half into acceleration is 4 meter per second square, and again time is 10 seconds, 10 whole square. 0 into anything is 0 plus, you can go for cancelling, 1s are 2s are, 10 square is 100, 100 2s are 200, 0 plus 200, it is 200. So S equal to 200 meter, unit is important. So conclusion, you can write the distance covered by the racing car. The distance covered by the racing car is how much? It is 200 meter. Clear? Now the first one is over. Let's move on to second one. Sorry, it is actually 6th problem. Just go through that. A train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration minus 0.5 meter per second square. Dear students, you know that when the brakes are applied to the vehicle, whether the speed increases or decreases, obviously it decreases. Then, so decrease in the speed, the change in decrease in the speed is nothing but negative acceleration that has been given. It is 0 minus 0.5 meter per second square. Next, find how far a train will go. Again, how far a train will go before it is brought to rest. Clear? Before that, after brakes are after applying the brakes, finally it will come to rest. Then final velocity will be 0. Understood? Okay. Now, first let's go for writing data. A train is traveling at a speed of 90 km per hour. So this is the initial speed we have considered that. So I write u equal to 90 km per hour. Now convert this into meter per second. 90 into, it is 5 by 18 meter per second. 1s are, it is 5s are. 5 5s are 25 meter per second. Got it? Next. So as to produce a acceleration, deceleration, it is a equal to minus 0.5 meter per second square. Find how far the train will go. That is, S is to be found out before it is brought to rest. Means when it comes to rest, the final velocity will be 0. V equal to 0. Now you are going to find out the distance covered before coming to rest. Then which equation of motion can be used? Observe it. A, V, U. Yes. A, V, U. S is not there. A, V is not there. Here. A, V, U. Yes. This is. Can we go for using third equation of motion? Yes. I will go for writing that. Again, from equation of motion, we can go for writing it as 2as equal to v square minus u square. Now 2 into what is a? A is minus 0.5 into s is unknown. It is equal to v, final velocity 0, whole square, minus u, initial velocity it is 25 whole square. Now 2 into 0.5 can be written as 5 by 10. 5 by 10 is nothing but 1 by 2. I write minus 1 by 2 into s equal to 0 whole square, 0, minus 25 whole square, it is 625. Now 2 get cancelled. Minus s equal to 0 minus 625 is minus 625. Minus minus get cancelled. S equal to 625 meter. Clear? And the conclusion can be written. See that? They have asked how far a train will go before it is brought to rest. So train covers a distance of 625 meter before coming to rest. Therefore, the train covers a distance of 625 meter before coming to rest. Before coming to rest. Clear? So these are the two important problems which we have solved based on equations of motion. Please go for copying from there to here. Quickly copy this. Now we have last two statements. Just go through. These are important. After this we will move on to the last concept of this chapter. This is the 7th one. Look here. A trolley while going down in an inclined plane. This is the trolley. Trolley while going down in an inclined plane has an acceleration of 2 centimeter per second square. Here whether the speed will go on increasing or decreasing. Every time it will go on increasing, right? So now it is 2 centimeter per second square. That is the acceleration. What will be its velocity 3 seconds after the start? 3 seconds after the start. Then that means first it was at rest. When it was at rest, what was its velocity? It is 0, right? Now let's go for calculating. Observe. First let me write the data. A trolley while going down an inclined plane has an acceleration of 2 centimeter per second square. What it is? It is acceleration A equal to 2 centimeter per second square. Is it in SI unit? No. Then what is the SI unit of acceleration? It is meter per second square. Convert this into meter per second square. 2 into centimeter is there. 1 centimeter equal to 100. 1 by 100 meter, right? Second square as it is. It is equal to 2 ones are 250 is 1 by 50 meter per second square. Next, what will be its velocity? That is the final velocity which you are going to find out. 3 seconds after the start. Time 3 seconds after the start. Initial velocity was 0. How do you go for finding which equation of motion can be used? See that AT again V equal to U plus AT, S equal to UT plus half AT square, 2AS equal to V square minus U square. Which among these can be used? See that AT, yes, all four are there. You can go for using this. Alright, V equal to U plus AT. It is nothing but acceleration only. It is A equal to V minus U by T. Both are same. Next, in this you are going to find out V. Cross multiply. Or else, first you go for taking substitution. What is it? It is 1 by 50. It is equal to V is unknown. U is 0. Time is 3 seconds. Clear? Next, go for cross multiplication. It is 3 by 50, which is equal to V minus 0. What is V minus 0? It is just V only. So V equal to 3 by 50. You can go for dividing 3 by 50. 0 point here 0. Next, again 0, 300, 6 are 300, 0. Hope that you have understood the division. It is 0.06 meter per second. So you can write its velocity after the start, 3 seconds after the start is 0.06 meter per second. Therefore, the velocity of the trolley after 3 seconds is 0.0 meter per second. Clear? Okay, now we will move on to another one. First you go through the statement. The statement may be lengthy, but it is easier. A stone is thrown in a vertically upward direction. A stone is thrown vertically upward direction. Imagine that a stone is going up with a velocity of 5 meter per second. With 5 meter per second velocity, you have thrown the stone. If the acceleration of the stone during its motion is 10 meter per second square in the downward, obviously when the stone is thrown vertically upward, it reaches some height. After reaching that, then it comes back. It is due to the gravitational force of the earth. When it is coming down, it is moving with a velocity of, acceleration of 10 meter per second square. When it is going up, again it moves with the 10 meter per second square acceleration. But as there is change in the speed, will go on decreasing. That is what we say the deceleration. Got it? Then what will be the height attained by the stone? One thing, height attained by the stone, and how much time will it take to reach there? See that here, it is the ground, and you are throwing the stone with a speed of 5 meter per second. Then with the velocity, if the acceleration of the stone, during its motion is 10 meter per second square in the downward direction. What about in upward direction? it is also same, that is 10 meter per second square. But when it is moving upward direction, we consider deceleration. Moving downward, we consider positive acceleration. Okay. So it is 10 meter per second square. What will be the height attained by the stone? See that, as we know, as it moves up, the speed will go on decreasing. Finally, it comes to rest in the at some point. So here it will be 0. What? Final velocity will be 0. Then, and how much time will it take to reach there from here? From here to here, how much time it has taken? That is to be found. Let's go for writing data. Here, a stone is thrown in a vertically upward direction with a velocity of 5 meters per second. That is the initial velocity with which stone is thrown vertically upward. 5 meters per second. Acceleration of the stone is 10 meters per second square downward. If it is upward, we have to write minus 10 meters per second square. Clear? What will be the height attained by the stone? Height. That height can be taken as that distance. I take this as yes. What will be the height attained by the stone? And how much time will it take to reach there? So when it reaches to highest point, its final velocity will be 0. V equal to question mark, sorry, V equal to 0 meter per second. And here you are going to find out the time. Let's go for calculation. First, observe it. What do you go for taking? UAVS. Which one? Which equation can be taken? UAVS. Can we go for taking 2AS equal to V square minus U square? Observe. UAVS. UAVS. All terms are there. Next, 2 into what is A? It is minus 10. Yes, it is unknown. V, it is 0 whole square minus U, it is 5 whole square. Next, it is minus 20. Yes, 0 whole square is 0 minus 5 whole square, it is 25. Now, minus minus get cancelled. S equal to 25 by 20. S equal to, cancel it by 5. 5 5s are 5 4s are. Then again 4 1s are 4. 1 will remain. It becomes 10. 4 2s are 8. 2 will remain 20. 1.25. This is the distance to 1.25 meter. When the stone is thrown vertically upward with that velocity, after some time it covers a distance of 1.25 meter. To cover this much distance, how much time it has taken, that is to be found out. Now we want time, which is going to be taken. See that? UAVT. So what is the equation can be used? It is V equal to U plus 18 or acceleration form. To find out the time, A equal to V minus U by T. What is A? Minus 10. V, final velocity 0. U, initial velocity 5. Time is unknown. Go for cross multiplication. It is minus 10t is equal to 0 minus 5, minus 5. Minus minus get cancelled. T is equal to 5 by 10. It is T is equal to 5 by 10 means 1 by 2 or 0.5 seconds. 1 by 2. T is equal to 0.5 seconds. Clear up? Now, so we can go for writing the conclusion. What is the conclusion? See, what will be the height attained by the stone? Therefore, the height attained by the stone, attained by the stone is, it is 1.25 meter. And how much time will it take to reach there? That means how much time it has taken to cover this much distance? It is just 0.5 second, nothing but half second. And time taken is 0.5 second, that is half of a second. The students understood both of them? Please, once you go through that correct thoroughly, then pause the video and start writing from there to here. So all numerical problems are over. Now we will move on to the last concept of this chapter. Yes, copy this. Now we are moving to the last concept of this chapter. Consider a body moving in the closed path. Now I am going to draw some of the closed path. Just keep observing them. This is first one. Just by observation only, you will be able to tell the shape of that closed path. Similarly, here also one more is taken. Observe this also. Next, third path is like this. Now we are using the mathematical concept for explaining. And again, I go for taking one more. Observe this closed path. Now look here. Here I have taken 4 closed paths. And this is initial position of the body. It starts moving along this path. It takes turn at this point, B. Again it moves along this path. Again it takes left turn at point C. Again it takes left turn at point D. Like this, it starts moving. See, could you tell how many times it changes its direction? Here, if it starts from A, it changes once, here twice, thrice, and if it has to continue, then it has to cross, it has to change its direction 4 times. Here, how many times it can change its direction? Here 5 times, here 4 times. What about in this case? You know that it has hexagonal shape. So 6 times, once, twice, third time, fourth time, fifth time and 6th time. What about here? Count it. 1, 2, 3, 4, 5, 6, 7 and here 8, right? Now, here the body is changing its direction at different points. Then what do you say about the speed of the body? Yes, it is. Can we say the speed of the body is changing? If the body is changing its speed, then can we say that its motion is accelerated? Yes, it is accelerated. Now I am going to take one more closed path. Observe. Could you tell in how many points it changes its direction? Here you cannot, because it takes plenty of points, right? Here also we can say that the body has accelerated motion. In this case, come to the last one. When the body is moving in this closed path, it takes the turn many times at many points. Then it is a circular path. Then can we say that the body is moving in the circular path? Yes, circular, it is nothing but curved path. So when a body moves along a curved point, around a fixed point, then we can say its motion is circular motion. Understood? When a body moves along a curved path around a fixed point is called circular motion. Now we will get more information about circular motion. If you want to take some of the examples for circular motion, that is, moon is revolving around the earth, then many other satellites are moving around the artificial satellites. Then Mercury is moving around the sun in the circular orbit, right? So these are some of the examples. When a body is moving in the circular path, can we find out its speed? Yes. How do you go for finding the speed? We have a formula to find out the speed, v equal to d by t. You assume that the body has started moving from this point in the circular path, and circular path has some radius, I call it as r. You may take capital R. If it completes one round, then what is the total distance covered by it? It is nothing but the distance around a circle, also called circumference. It is 2 pi r. And the time taken by the body to complete one revolution, it is period of revolution. It is denoted by the capital T. So V equal to 2 pi r by capital T is the formula used to find out the velocity of a body or the speed of a body moving in the circular path. Again, you just go through these figures. In all these cases, the body is taking turn at some points. When it is changing its direction, the speed changes. Here also, in fourth one, what about in fifth one? It keep on changing its direction at every point. Then is it possible for a body to move in the circular path with a constant speed? Yes, certainly. Example again, the moon is revolving around the earth with a uniform speed. When a body moves along a circular path with uniform speed, then we can call that as uniform circular motion. Understood? Uniform circular motion. Let me tell you the definition once. When a body moves along a circular path with a constant speed, then its motion is said to be uniform circular motion. And in case of circular motion, when a body moves along a curved path around a fixed point is called circular motion. And for uniform circular motion, you can take the examples. Moon revolves around the earth and other satellites revolve around the earth. Then Mercury revolves around the sun. And when you take the clock, in that the arms will be there, 3 arms, second arm, hour arm and minute arm. You just observe their tip. The motion of the tip of these arms of a clock, they will also represent uniform circular motion. Clear? Now, assume that a man has taken the thread. At one end of the thread is tied to a stone and he is holding the other end and start whirling over his head. Like this, I will go for drawing. See that. When he is whirling that, then the stone, it takes the motion. What type of motion? It is circular motion. Right? Then suppose the thread is broken somewhere else, or else he has released the thread. Then could you tell in which direction the stone moves? Here, if it is moving in the anti-clockwise direction, this is the position of the stone. At this position, the thread is broken. Then the stone moves in a straight line like this. And this is what we say the tangential direction. Hence, we can say that when a body is moving in a circular path, it changes its direction and that direction will be in the tangent, direction will be along the tangent. Got it? See that if it is broken at this point, it moves in this direction. Here, if it is at this point, it moves tangent to the circle in this direction. Clear? Okay, now I am going to write the definition of circular motion, uniform circular motion with examples. You have to write with me. Dear students, here I have given the information about circular motion. Please observe this. First, definition of circular motion has been given. When a body moves in a circular path around a fixed point is called circular motion, and I have given some of the examples as well. Next, after writing this, you have to write the speed of a body in circular motion. Then, that is, when a body is moving in the circular path, you can find out its speed by using this formula. V equal to d by t, that is common formula, and distance is to be, if it completes one round, we take c. If it completes 2 rounds, we go for taking 2c, nothing but circumference. And v is equal to, circumference is nothing but 2 pi r divided by t. This is the formula. So you have to write this again, then draw this figure, then go for writing this formula. Next, we have come to know that the different closed path in which the body is moving and how many times it changes its direction. So here 4 paths are given. You have to write this one. Then after this, I have given the definition for uniform circular motion. When an object moves in a circular path with a uniform speed, then its motion is called uniform circular motion, and these are the 3 examples. Okay, so quickly pause the video and copy from there to here. Yes, copy this. Okay, dear students, here I have drawn a figure, and with respect to that figure, 3 sub questions are there, and these 3 questions were asked even in the examination. The same questions are written. Look here. Here they have given a stone and it is tied to a thread, and other end of the thread is held by a man, and he started whirling the stone. It may be moving in this direction. Observe. Answer the following questions with respect to the above diagram. This is the diagram. Could you tell, the first one is, what type of motion experiencing by a stone? Yes. What type of motion? It is, you can say that it is moving in a circular path. Hence it is experiencing circular motion. Right? If the speed of the motion is constant, then you can say that it is moving in uniform circular motion. Right? Here we can write the answer. Stone is experiencing, what we can write? Circular motion. Next, second. What is the direction in which the stone moves after it is released? When it is moving in the circular path, somewhere else it is released or thread is broken. In which direction it moves? If it is coming in this direction, it moves in this, and we call the direction as tangential direction. So stone moves in a tangential direction. Then you all may be thinking that what is a tangent? Let me tell you that. Look here. Here we are going to use the mathematical concept to give the definition for tangent. This is a circle with center O, and here is a straight line. The line is away from the circle. Now the same line is brought near the circle, close to the circle. Now observe, the same line is brought very close to the circle where it touches the circle at a single point, and we call such a line as tangent. Hence you can define tangent as the line which meets the circle at only one point is called tangent, and this point is called point of contact. Clear? And you all may be thinking that suppose if the line is pushed again, what happens? It will cross it will intersect the circle at 2 distinct points. In such condition, this line is called secant. Clear up? The line which meets the circle at only one point is called tangent, and the point at which where the circle and the tangent will meet is called point of contact, and the line which intersects the circle at 2 distinct points is called secant. Just information. Next, go through third sub question with respect to that. Which force keep the stone to move in the given path? See, this is the path in which the stone is moving. What is the shape of that path? It is in circular shape, right? Then here the force is acting. Then what? When you are filling the stone with a thread, holding the thread at the other end, then you will experience that a force is towards you, and we call that force as centripetal force. The force which keeps the object to move in a circular path is called centripetal force. Got it? Here we can write answer as centripetal force. Then you may apply this to our solar system. In our solar system, Sun is at the center and all other planets are revolving around it, right? Then what has made which force or what has made the planets to move around the Sun? Yes, obviously you say that it is gravitational force. Understood? So in case of those Sun and the planets, centripetal force is provided by the gravitational force. Here centripetal force is given by the thread. Yes. Now you are going to copy from there to here, and before that just I'll go for writing the definition for centripetal force, tangent and secant. Here just tangent. What is tangent? A line which meets the circle at only one point. A line that meets or that touches the circle, that meets the circle at only one point. One point is called a tangent. Okay. Then secant, I hope that you can write the definition. A line which intersects the circle at two distinct points is called secant. Centripetal force, the force with which or the force which keeps the body in a circular path is called centripetal force. Okay, the students, with this the chapter has been completed, and still we have another part. We are going to answer for exercise questions. Now let me go for starting that, and before that you just copy from there to here. Draw the figure, write this question, and these are the sub questions. Go for writing with the answers, and after that write this definition for this heading tangent. Then draw this figure and mark all these. Okay, quickly. Yes. Now let's move on to the very first question. Observe it. In exercise, first question is this: an athlete completes one round of a circular track of diameter 200 meter. This is the diameter, 200 meter. In 40 seconds, an athlete completes one round in 40 seconds. What will be the distance covered then, and the displacement at the end of 2 minutes 20 seconds? Okay, so total time that he has taken is 2 minutes 20 seconds. After 2 minutes 20 seconds, how much distance he will cover, and what will be his displacement? That is going to be found out. Yes, let me write. Look here, they have given diameter. Diameter of the circular path is 200 meter, and the radius will be 200 by 2 because it is half of the diameter, which will be 100 meter. And the time taken by the athlete to complete one round is 40 seconds. Here all right. Time taken to complete one round, that is equal to 40 seconds. You can just remember one problem, farmer problem. There it was a square field, but here the circular track has been given. And the total time for which he has moved, it is 2 minutes 20 seconds. Total time Total time it is 2 minutes 20 seconds. Let us go for converting that into seconds. 2 minutes means it will be 120 seconds plus 20 seconds. Altogether it will be 140 seconds. So with this information, you are going to find out the distance and displacement after 140 seconds. Here, look at it. If it is so, what is the, we know that he has taken 40 seconds to complete one round. That means how much distance he will cover in 40 seconds? It is nothing but circumference of that circular track, right? So let me go for that. Distance covered in one round, it is equal to that's equal to perimeter of the circle. Perimeter of the circle, it is equal to 2 pi r, 2 into 22 by 7, where radius is 100 meter. It is equal to 22 2s are 44, 100 by 7. So this much distance to be covered if he has completed one round. Now look here. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? So in 2 minutes 20 seconds, how many rounds he has completed? Let us come to know that. See, number of rounds completed in 2 minutes 20 seconds is nothing but 140 seconds. It is equal to 140 divided by, to complete one round he has taken 40 seconds. It is 0 0, 7 by 2, 2 2s are 2 7s are, it will be 3.5, nothing but 3.5 rounds. Now 3.5 rounds, how much distance he has covered? Distance is equal to 3.5 rounds or 3.5 or 7 by 2 into circumference. That is now you are going to find out the distance covered in 140 seconds. Yes, completed 3.5 rounds. 3.5 rounds can be written as 7 by 2 into circumference. That is distance covered in one round. Already we have found out that it is 7 by 2 into, it is 4,400 divided by 7. 7 get cancelled. It's equal to, cancel this one. 2s are 0s are 0s. So this is the distance covered by the athlete in 140 seconds, nothing but 2 minutes 20 seconds. Now let's go for answering another one. Look here, and the displacement at the end of 2 minutes. Displacement at the end of 2 minutes 20 seconds. If he has completed 3.5 rounds, suppose this is his initial position. See that this is one round, he has completed 2 rounds, completed 3 rounds, then 3.5. He comes to this position. Got it? Then the displacement will be AB. Clear? So here I write, let the initial position of an athlete, let it be A. Then the position of athlete after 3.5 rounds. After 3.5 rounds is what? It will be at B. Is at B. So which is nothing but diameter. Hence I can write displacement equal to AB. AB is nothing but 200 meter. Clear? So the distance covered is 2200 meter and displacement is 200 meter. conclusion. Therefore, the distance covered is 2200 meter and displacement is 200 meter. Yes. Now you have to copy from there to here, and here we have found out the distance covered in one round. It's not necessary. You may go for finding that here only directly. Yes, here. Yes. Go for copying from there to here quickly. Yes, dear students, just we have finished only one problem in that exercise. Total 10 problems are there, and in tomorrow's class we are going to cover the remaining 9 questions. Okay, and before concluding the class, let me remind you again, it is whatever we have covered, please work out on the same day itself. Don't keep anything pending. And as we have covered the first lesson in physics, that is motion, so its unit test will be conducted on Sunday. So get ready for that. With this, let us stop the class. Thank you.